Hello all, welcome back. And this time we are going to do a transient or time domain simulation for the differential amplifier as shown. And as opposed to our previous modules where we applied the differential signals at both the transistors, now we are applying a single-ended signal to the transistor. So what you see here, we have applied a sinusoidal voltage source. I right click here to the base of the transistor Q1. So it has a DC offset voltage 0, 10 millivolt peak signal at the frequency of 1 kilohertz. And I'm expecting 10 cycles to run. And I click OK. And to the base of the transistor Q2, I don't apply any external signal except that there is a DC bias level of 0 volts set to both Q1 and Q2. Here also, I'm using the DC offset voltage field to set the DC bias level of the transistor. I would have a linear amplification of the applied input signal as long as I will maintain the Q1 and Q2 in the active mode or the linear region of operation. So I have on the base of these two transistors 0 volt bias. I have 5 volts at the resistors on top of resistors at the collector. I have used the resistor RE to set the emitter currents, which is called as tail current for the differential pair. And unless I make sure that my base emitter junction is forward bias for both Q1 and Q2, and collector base junction is reverse bias for both Q1 and Q2, I'm not going to get a linear amplification of the signal. So I have ensured that in our previous modules, we have demonstrated that. So if you are new to that, refer to those earlier models. So we have done that using the .op analysis to make sure that we have done the DC analysis and transistors are biased in the active mode of operation. And now we are doing a single-ended input and differential output analysis. So let's run the analysis. So for that, you see, I have enabled the transient simulation where I am using a stop time about 10 millisecond because my signal frequency is 1 kilohertz. So I have a 1 millisecond time period. So 10 millisecond, I am using the stop time in within this, it will capture. It starts from 0 to start saving my data. And at 1 milliseconds, every 1 milliseconds, my data will be plotted. So once I input those fields, I have the SPICE syntax ready, .tran 0, 10 milliseconds, 0, 1 millisecond. So I click OK, and here is that command. Other commands for a moment I have disabled. So let's run the analysis and see our results for a single-ended input and differential output. So on the graph, on the top pane, I see the VB2, which is the 0 volt. So here is a green line that you see. Then VB1 is varying as a 10 millivolt peak signal at from 0 volt bias again as a DC bias level. And it is giving me 10 millivolt up and down. Now it's time to plot VO1 and VO2, which I have done in the second pane. I see that I have a DC bias level of 1.4 volt at the VO1 and VO2. And from that, I'm getting an amplified signal. So 1.4 to 2.1. So it's about 700 millivolt. So for applied 10 millivolt, I am getting 700 millivolt. So you can see that the 70 times gain, I am having that, right? So here it is same for VO1 and VO2. Obviously, the signal is applied to transistor Q1 and VO2 is going to be in phase, but the blue line VO1 is going to be out of phase because this end is inverting amplifier. And if you apply input here and take output at VO2, is going to be a non-inverting case. So that's the advantage of using a differential pair to get both inverting and non-inverting within the same circuit. Now I wanted a difference output because the gain is doubled in that case. So you see the DC bias level is going to start from 0. Why? Because the DC bias level for VO1 and VO2 are at the same 1.4 volt. So their subtraction gives me a 0 DC bias level. And from that, I have about 1.4 or 1400 millivolts. So I apply about 10 millivolt, I get about 140 times gain. So my signal is amplified 140 times. And the gain of this amplifier, you can say it's GM times RC. So GM is DC collector current divided by the VT, which is a thermal voltage. We have done that theoretical calculation in our previous model. So hope you like this video. If you did so, click the like button, share with others, and do put some comments based on what you think about it. And stay tuned for more informative contents like this. And till then, wish you happy learning.